Hi, welcome back to your new lesson. This is Lakshmikanta Tiwari. In this lesson, I'm going to show you how you can do text generation using a TensorFlow, Keras and LSTM. So the first of all, I'll describe you how we are going to generate the text. But before that, I need to explain you how we are going to build the data, and then how we are going to train the model, and then finally how we are going to do a prediction. And then I'll be talking more about the data preparation. Most of the almost first 30 or 40 minutes you need to prepare the data, otherwise your algorithm might not work well. So a data scientist should devote its time in data preparation instead of just writing and building the models. So once the data is prepared, then I'll show you how you can build LSTM models and prepare your training and the testing data set. And then finally this LSTM model will be built, and then the training will be performed on 100 epochs, although you can increase. Okay, so without wasting your time, let's go ahead and start this brand new lesson. In this lesson, I'm going to tell you how you can generate a text by using a TensorFlow, Keras and the LSTM. So this is the particularly in which I'll be training deep learning model, especially the LSTM model, by converting its word into a vector. All right. So it is kind of in which this the deep learning model will be learning to predict the next word on given some particular the sequence of words. For example, in the step 1, let's say if we have the man is walking, then the model will be predicting down, and once down is predicted, then it will be again taking, let's say, last 4 word, and then it will be predicting the next word, and then similarly this next word will be included into the seed sequence of the words, and in which it will try to predict the next word, and so on. So it will keep going and it will keep predicting the next words, and then the next word will be included into a seed sequence of words, and then it will predict the another next word. Okay. And but the question is how it would predict the next word. To make it predict the next word, we need to learn our deep learning model, and to make it learn, we need to provide some data, and that data should be in the text format, and later that text format will be converted into integer formats or in a vector, and that will be encoded there, like word embedding techniques. And for that I have chosen the work done by Shakespeare, William Shakespeare, and it is the sonnets. So this is the play name done by William Shakespeare. So this is the quite large text, and you see here this is quite large text, and it is available at MIT website ocw.mit.edu. I have provided the link for this as well in the video description. From there you can download. All right, perfect. So this text we will be using to train our deep learning model. So let's go ahead. The first of all, what we need to do, we need to first import this text into our the Google Colab notebook, and then after we will be cleaning this text, and then we will be preparing it so that we can use it into our deep learning model. So the first of all, in Google Colab you need to set your runtime, and that runtime I'm going to use here GPU. So set its GPU there. Once it is set, you can get click on the connect, otherwise it will automatically get connected. Once it is connected, then you will see here a RAM, and the disk will be initialized. So initially the RAM, 12 GB of RAM is initialized, and 68 GB of hard disk is initialized for this notebook. but later you will see that this 12 GB RAM is not sufficient to train this model. So the Google will automatically crash this the Jupyter notebook, and once this Jupyter notebook will be crashed, then it will ask you to increase the RAM, which will be automatically upgraded to 25 GB. Okay, so without wasting time, let's go ahead and start the coding. Since we are gonna use here TensorFlow version 2.0, that means we need to give here a magic command there, so that we can get with the TensorFlow version that we are gonna use here 2x. And then I'm gonna import here a TensorFlow. Okay, TensorFlow as TF, and I'm also gonna import a string, and I'll be needing this string for a punctuation. And apart from that, I'm also gonna import the requests so that I can get this text file into our Jupyter notebook. So let's go ahead and run this cell. Once you run this cell, it will import all these three necessary libraries, and it says that TensorFlow 2.x is selected. That's the TensorFlow 2.0. Very recently it has been launched. Now let's go ahead and read this text directly from the internet that we can get with the response is equal to request dot get, and there we need to provide this link. And once we provide this link, then hit the enter, and once this is done, then you can type their response.text and you can print this text. So this whole text has been returned by request.get, and it might take a little time to fetch all the text, since this is a quite large text and it has the more than 20 lakhs of the word there. Alright, so this is very quite large text. You see it has been extracted here in a Jupyter notebook. The one thing you might notice here is that there is new line character, and this new line character is inserted at every new line, like you see here. So these are the new line. This is the 100th EE text file presented by project Gutenberg, and after and you see here a new line, and from there is new line. So you see here and after new line, and from there is new line. Alright, so that's the new line character is inserted here. To make it something like this, we need to split at new line character. We will do that later. So once we have got the response dot text, then you can get this data using this response dot text, and then split it at new line. So once we do this, we will get a list of string there, and let's go ahead and print the very first line, and that very first line is this is the 100 e-text file presented by project Gutenberg. And the one thing you see here, this is the header file, and this is not original work of the Shakespeare. The work of the Shakespeare starts from the line number 253. You see here, so this is the line number 253. I'll show you. So the work starts from here. So what we need to do, we need to omit the initial line. So let's go ahead and see line number 253. That's the data 253. It says that here, from fairest creature we desire increase. Now you see here, from fairest creatures we desire increase, that thereby beauty's rose might never die, but as the reaper should by time disease. Okay. So we need to update our data with this point that we can do here. The data is equal to the data list will start from 253 to by the end. Okay. So with this we get here our updated data. Now at the 0th location we have very first line of original play. So this is how we have removed our header from the file. Now once we have removed the header, we have got the original work here. Now what we need to do, since this is the list and you see here the length of this data, it will show you that how many lines are there. So it says that there are 124,000, more than 124,000 lines are presented in this data, and to make it a continuous text, what we need to do, we need to join all the values presented in this data. That we can do something like data is equal to, okay, dot join and then data. So this list will be converted into a text, and there you see here the data is there. The new line character has been removed, and the header is also removed. So this data will print the whole play, but after removing this header, that's mean from this line to the end of this play. Okay, it might take a little time to print it. Perfect. So you see here, from the fairest creature we desire increase, that thereby beauty, rose might never die. But you still see here there are few the punctuations, like here there is punctuations, and here is punctuation. So what we are going to do here, we are going to remove these punctuations, and then there will be just alphanumeric text, and that text we will finally train our deep learning model based on those text. So what we need to do here, we need to first write our cleaning function. So I'm gonna write a clean text function that will take this document, and we need to first, what we need to do, we need to create it a token. We need to create a token. The token means what we need to do here, this will be splitted with the space character, and these are the particular tokens. Okay, so the tokens is equal to doc.split. Okay, and this split will be based on the white spaces, and if there are more than one white space, then the another white space will be included as a token. And then finally I'm gonna get here the punctuation. So that the punctuation we can get with the str dot make trans. Okay, this is the technique to remove the punctuation from any string dot punctuation. All right, so here we have tokens. Now the tokens is equal to w. The one thing you need to see here, this is a list in which I am gonna I'm gonna put a for loop there. So for w in tokens, so you see here the token is individual words, and I'm putting here a for loop, and this w will be returned here, and for that I'm gonna create here I'm gonna create here a function, I'm gonna create here a list which will not include the punctuation. That's when the punctuation will be removed. That we can do here, w dot translate. All right, so we have here w dot translate underscore table. All right, so with this will be the translated here. So with this, in the new token, the punctuation will be removed here. All right, so after this, what I'm going to do here, the tokens is equal to, there I have word, but before that, let's say here we have a token, and now I'm going to remove here a special characters which are not alphanumeric. Okay, a special characters which are not alphanumeric. So to do that, I'm going to do here word in tokens. Okay, actually not word, in fact I need to do here a for loop. So I can do here a for word in tokens. Okay, so here we have a for word in tokens, and if word dot is alpha, you know what it will do? It will check here if this word dot is alpha, that means this word, if it is alphanumeric, only then this will be saved in this new string. That's the word. Okay, perfect. After this, once we have got this, now we need to convert it into lower, okay, into a lower text.
To turn it back on, slide the switch on the back of Google Home.
Yeah, sorry, so I had a Google Home, so it has just turned on and it is asking me to turn on its microphone. Okay, nevertheless, let's go ahead and start this one further. Okay, so here we have, now we have got our token which have removed any special characters and the punctuations, and now we need to convert these capital letters into lowercase letters, and to do that we need to do here tokens is equal to word dot lower. Now I'm sure you understand this now, for word in tokens. All right, so with this, you see here what happens. So this token has been converted into lowercase letters, and it has removed any special characters from here, and it has removed any punctuation by using these two lines, and with this line of code it has splitted this full text into tokens, which is white space separated, and if there are more than one white space, then it will automatically add that another white space as a token. Alright, so let's go ahead and run this. It's saying that unable to connect at the runtime because my runtime got disconnected. I need to again reconnect it. It is saying that there is some problem. Let me see. I think my internet got disconnected. That is why it is happening. Let me get connected with my internet and then I'll start it again. Alright, so once I got connected with the internet, I had reloaded and reconnected my the Jupyter Notebook runtime. So I have not changed any data here. Previously it's exactly the same as I told you earlier. Okay, so let's go ahead and run this cell in which I have written a function to clean the text and to remove any non-alphanumeric characters and punctuation and any extra white spaces. So let's go ahead and get the tokens. That we can get with the tokens is equal to clean text. Okay, in the clean text we need to pass here data, and once we pass this data, let's go ahead and print first few token. So I'm gonna print here the initial 50 tokens, which we will be using as our seed text. Okay, these 50 text will be used as a seed text. So it says that something built in lower str object. I think here I have a little mistake here. Let's go ahead and run this and run this. Now everything should be fine. From fairest creature we desire increase, that thereby beauty rose might never die. Now you see here these special characters and punctuations have been removed from these token. Now once we have got these token, now we can finally combine these tokens together to get a full the characters, full text. But before that, let's go ahead and see how many total number of tokens we have. The total number of tokens we can get with the length of the tokens. It will say that the total number of words present in this play. So it has 898,000. Okay, 898,000 words present, the total number of the words. But how many individual words are there? So if you want to know any unique words, the unique words, we need to convert it into the set, and then we need to pass this list in its set. So with this we will get total unique words. So the total number of unique words are 27,956. So we can say that this will be our total the vector size during word embedding. That's mean in this full play there are 27,956 unique words are there, and the combination of these words are being used to create here 898,199 total number of words in this play. Like there could be many repeated desire and repeated increase. That is why the total unique number of words are less, and of course the combination of these unique words are high. Perfect. So let's go ahead and create the sequence, the data sequence in which we will be using to train our model. So as I told you earlier that we will be using the particular set of words to predict the next word. So in this lesson I'm going to use a 50 set of previous words. Okay, so in this example there is just 4 words, but I mean in this figure here. Otherwise in this example I'm going to use, there is such 50 words, and then after this 50 words we will be predicting the 51st word, and then I'll be again taking the 50 words and then I'll be predicting the 52nd words, and similarly I'll be creating the number of lines here. So let's go ahead and prepare the data for that one. So what I'm going to do here, I'm going to say that length is equal to 50. That is for as an input, and since I'm going to also predict the output as well, so that's the 50 plus 1, that's the 51. So how I'm going to do this, I'm going to first create these the 51 together, and then at the final stage I'll take this the last column as output, so that I can train the model and I can prepare the data. I'll tell you that later in very detail. So for time being you understand that the first 50 is input and this is the output for which I'll be training this model. And then here lines, we have a line which is just an empty list. Now let's go ahead and create here a for loop for I in range. There we have a length, that's the 51 here, and total length of tokens, so how many tokens we have. Now once we have this one, the for I in range, length, and then the length token, after this what I'm going to do here, I'm going to create a sequence here. So that's the sec is equal to, let's say, sequence is equal to the tokens, and inside this token we have our I minus the length. Okay, so here I minus length to I. Now you see here this range will start from length, that's the 51. So the 51 minus 51 is the 0, and then it will go to I, that's the I starts with 51. So the 0 to 51, and that will come in the first sequence. And then what I'm going to do here, you see here 0 to 51, and once we have got these individual tokens, then I'm going to join these to create a sentence. So and to do that, I can do line is equal to dot join and then sequence. So it will create a line there. And once we have that one, once we have one line, that is the sequence of 51 words, and then that sentence I'm gonna feed it into this empty list, that is the lines dot append, and in that I'm gonna put this line. Once we have this one, now the one thing, if you remember that I told you that this RAM, 25 GB RAM is not sufficient to embed this the full play, which have more than around 1 million the word, so it is not sufficient. So here what I'm going to do here, I'm just going to take initial 200,000 words, that's mean just 1/4 of this total play. Otherwise this RAM will overflow and you will not be able to you will not be able to train this model. So here we have if I is greater than 200,000, okay, then break. All right, perfect. So with this, what I'm going to do here, I'm going to see how many sequence we have total that we can get with len of lines. So you just run it. It might take a little time to get it complete. It says that total we have got 199 lines, 199,000 line, around 200, you can say around 200,000 lines data. So inside these lines, you see here at the 0th location, we have first 50 words. If you remember this from fairest creature, we desire increase that thereby beauty rose. And you see here we had a sequence, we had a tokens here. All right. Now you see here at the tokens, the 0th location of that token have this from, and if you want to see here the line is a 51 word. Okay, so this 51 word which we have here is a self. So let's go ahead and see what it has at the 50th location. That the 50th location is 51 word. So let's go ahead and see the token 50 is having self. That's means 0 to 50 is 51 word total. Okay, and now you see here lines. Now you see here lines 1. Lines 1 will have the token from fairest to the another word. Okay, I mean just next word from a self. Okay, that's the die you see here. So how it will work? It will first take these the first 50 words, then it will try to predict the self. I mean it will first learn, and then again it will take this, it will include this self into input, and then finally it will try to predict this final, the output, and the so on. So this is how this the algorithm will be designed. Okay, now the time to start building our LSTM model. So I can just write here build LSTM model and prepare X and Y. So as I told you earlier that I'll prepare this X, these X and Y in a way that the first 50 word will be used to predict the Y. Since each of these line is having 51 words, that's mean the first 50 words will be used to predict the 51st word. Okay, so before we start building our LSTM model and preparing our X and Y, we need to import necessary libraries and the packages. So here I'm gonna first import NumPy as NP, and I'm also gonna import the Keras library from TensorFlow, TensorFlow.keras. Let's go ahead and copy this. We will be needing this many times. Pre-processing. Okay, so in this pre-processing text, we will be using the tokenizer which comes with the Keras inbuilt, and then from TensorFlow.keras utils import to underscore categorical, and then we have here from TensorFlow.keras and .models import sequential. Okay, and then here we have from TensorFlow.layers import dense, and similarly we will be needing here in that layer not only just dense layer, but we will be also needing here LSTM as well as embedding layers. I'll tell you why we will be using these embedding layers. And Then finally we will be also loading here the pre-processing dot sequence. There we will be using the padding as well, sequence import pad sequence. Okay, so these are the necessary packages which we will be using throughout this lesson. So it says that that should be actually import np numpy as np. Perfect. So we are gonna first work with the tokenization. So let's go ahead and create this tokenizer. We have here tokenizer is equal to tokenizer. Okay, and then here we have the tokenizer dot fit underscore on texts. So what we are going to do here, we are going to fit these lines first on the tokenization, and then this tokenization, I mean the sequence of word will be embedded as an integer actually. Okay, this is kind of the word embedding in which these every unique word will be assigned an integer. Since any machine learning algorithm works on only numerical values, we need to convert these text data into numerical values, and that is being done by the tokenization here. So once we do that, then we are going to create here a sequences is equal to tokenizer dot texts to sequences, and in which I'm gonna put here lines. All right, so once we have done this, tokenizer dot fit on text and then sequences. So this sequences will be having a list of the integer value which is created by the tokenization. So let's go ahead and see these sequences. Now once you print these sequences, you will see something of the very big array actually. I should not have printed this array, it might hang my computer as well. Okay, so this is the quite big array there. Okay, this is quite big array. So what we need to do, we need to convert these sequences into a numpy array. So the sequences is equal to np dot array, and then here we have sequences. Okay, so once we have these sequences, now we need to as I told you that I should not have printed that, it might have crashed my the notebook. Let's see. You should always avoid to print any large sequence, otherwise your notebook might get crashed. So let's wait for some time as well, otherwise I need to restart it. Now you see here the RAM is still 12 GB. Let's stop this. It is not getting stopped. Yes. So it is saying that I need to restart my Jupyter notebook, otherwise it will not work. Okay, so that's the mistake I did. I printed this whole sequence. You should not print the whole sequence, otherwise your notebook might get crashed. All right, so what I'm gonna do here, I'm gonna exit this page. All right, so I had reconnected my the runtime. It might happen to you the sometimes when your output gets very large, your Jupyter notebook might get disconnected. You need to restart it again and run all the cells. So I did the same. Here the number might have changed here. It was earlier the 23, but now it is the 19. But I have not changed the code a bit there. So all the code is the same. Okay, I have not changed anything here. So the code is same. I had just rerun all the cells. So I had to do that so that it can get connected again. So we were here, I was creating sequences is equal to np.array sequences, and now I'm going to create x and y. Now do you remember that I told you that the first 50 sequence, first 50 word will be used for the input vector, and the 51st word will be used for output vector, that is y. So the same here I'm gonna do here sequences. And now you see here the sequences is kind of the two-dimensional array which have rows and the column. So the rows represents that the line of play, and columns, that means word column, and there are 51 column. The first 50 column is x and the 51st column is y. So in which I'm gonna select all the rows, that is we can select with this column, and then I'm going to select all the column but last column. That's mean it will now select all the column but to last column. That's mean till 50 column it will select the data for all the rows that will go into x. And now for y, here we have sequences. In this we need to select all the row but only the last column, that we can do this one. So you see here there is just a minor difference. This column says that select all the column but last one, but this one says that select only the last column, which is the output and which will go into y. Alright, so with this you will get here x and y. Now you can see here the very first the line, that is the x0. So this is the vector. Now this vector, the size of this vector is 50, and here the number says that this is the integer value for a particular word. So this is kind of the word embedding. In the word embedding, you will see that each unique word will be assigned a unique digit, and based on these digit sequences, a final output which is, let's say, a y0. Okay, so based on these sequences, now if you have a deep learning, knowledge of a deep learning, now you will find that this is kind of now has become a traditional problem in which we have a sequence of numbers and we need to predict the final output as a number. Alright, so now we have x and the y in the form of the number. And the one more thing you see here, the y0 is saying that here the 307, that is the code of a particular word, but we need to change this y into a one hot encoding, that we can do the y is equal to the two categorical, so that we can also print the probability of each predicted word. So here we have y, two categorical y, and the number of classes, how many number of classes we have, the total number of classes is vocabulary size. Okay, so we need to get the vocabulary size, and that we can get, you see here, so 27,956 is vocabulary size. Okay, so for that, how we can do that? Let me see here, the vocab size here we have, I think let's go ahead and print here vocab size, the vocab size. But before printing the vocab size, the one thing I should show you here, that's the tokenizer dot word underscore index. Okay, so if I print this, you will see here the index for each word will be printed here. All right, so the index for each word is printed here, and let's say this 455 is corresponding to hell, 454 is corresponding to the virtue. Okay, so this will tell you the total length. The one thing you see here, if I show you the very first, which is 1 or 0 perhaps. I think that should be the 0, the 1 here. You see here 1, the, and I 3. Okay, so the is 1. So in this way, what I'm gonna do here, I'm gonna print here the length of this, the total vocabulary. So you see here the length of total vocabulary is saying that total 13,008. Okay, since this is from the first location, from the first we need to add here +1 as well, so that we can get the right vocabulary size. So here we have vocab underscore size is equal to tokenizer.word index +1. Okay, so with this we have got total vocab size. Once we have this total vocab size, now after removing the punctuations etc., so this number has been reduced earlier, which we had seen there, unique words, which was here perhaps. Okay, I think after this the total number of unique word is removed. Okay, after lines. Perfect. Otherwise in the original text the total number of unique words were 27,956, but the currently only 13,000 left because we had reduced the total the size. Alright, so the number of classes which we have that comes with vocab size. Alright, so here we have got our the y and the sequence length which we have actually that is the x dot shape 1. Sorry, the 1 is always 50 there. You see here we had because taken the first 50 word to predict the 51st word. So this y is equal to the shape which we have currently there. I'm gonna I'm going to store this into sequence underscore length is equal to x dot shape at the first. So the sequence length is here defined as a 50. Alright, now we are going to build our LSTM model. So this is where I'm going to build my LSTM model. Till now it took almost the 40 minutes to prepare the data. Now I'm going to make a LSTM model and then finally I'll train this model. So the model LSTM model which I'm going to create is going to be very simple model. So model is equal to sequential. If you have not seen my previous videos, please go ahead and watch those videos. I have talked about these sequential models and LSTM in very detail there. So you can create sequential model by calling model is equal to the sequential. Since we are using here word embedding, so I'm going to also use here embedding there. So in the word embedding, it asks about what will be the input dimension. The input dimension which is here, that is the vocabulary size, the embedding, word embedding, total vocabulary size that we have vocab underscore size. And what will be the output dimension? So there will be just 50 output. So this is kind of the encoding what we are doing there. So there we have total around 13,009 vocabulary the words, and in that we are going to produce just 50 words. And then it asks about input length. Okay, so the input length which we are going to use, that's the 50 as well. So there we have sequence underscore length. So with this we have got our model, the first embedding layer, and then model dot add. There I'm going to use 2 layers of LSTM model. So there we have LSTM, and each of these model is gonna have 100 hidden layers. And since we are using here the 2 layers, so we need to also use return sequences. So let's go ahead and add the final layer of LSTM, which also have 100 hidden layer. And then we are not gonna use another LSTM layer. So by default return sequences will be false here. And after that I'm gonna use here dense layer, and then the dense layer I'm gonna use here 100 the units of dense layer, 100 neurons in dense layer, and the activation function in the last which I'm gonna use there is ReLU activation function in this dense layer. And then at the final layer, which is also a dense layer, right? But here it is very important to understand that the total number of units in final dense layer will be the size of vocab, because we are going to predict the probability for each word. And then here the activation function will be a soft max, so that we can also get the probability for each predicted word. Alright, so after this we are gonna run this, and then finally we will print the summary of this model, which we can just get with model.summary. Now you see here, this is the summary for this model. Alright, so there are total more than 2 million parameters in this model. So this is going to take some time. If you are doing this on the Google Colab notebook, that is gonna take some time. The one thing you should also notice here is that the RAM is almost full. That's the 11.3 GB is full out of 12.72 GB. So anytime this notebook can get crashed, and after that the Google will ask you to increase the RAM, which will then automatically get increased to 25 GB. Alright, after that what I'm gonna do here, the model.compile, and in this I'm gonna use here a loss function that will be used categorical cross entropy. The optimizer is equal to Adam, and then matrix is equal to accuracy. Alright. Perfect. So we have here model.compile. Now after this we have reached into a very interesting mode in which I'm gonna call model.fit. So this is the final stage of this model building. Now it will train this model, which is definitely gonna take a time. And there we have input X and then final Y output. The batch size which I'm gonna use here is 256, and you can change the batch size. Epochs, I'm gonna train it for 100 epochs. The one thing before I start it, let's go ahead and start this, and then I'll be telling you. The first thing, it is going to take a lot of the time. On the Google Colab it might take around an hour to complete this training. And the second thing, this get crash, and yes, it has got crash. Okay, automatically it is restarting, and it might ask get more RAM. Okay, yes, and yes. So now you will see here it will get 25 GB of RAM, and all the previous work is deleted. Now you see here we have got 25 GB. So what we need to do here again, we need to restart runtime and run all. So this is going to take some time. The one thing is sure, we are not going to change any code. It will automatically come here and then it will start fitting the model. So it might take time, the first one. The another one, your notebook might get crashed because of the low RAM. Then it will ask you to increase the RAM. Okay, get it increased to 25 GB, and then it's gonna the accuracy is not gonna be very good, because we have just considered 1/4 of this play, And the another one is because I have increased batch size to 56. So if we increase the batch size, then the accuracy might get decreased, but the training time will be the faster. And the number of epoch is just 100 there. So the number of 100 epoch is not quite good in this case, at least in this model. So you might need to train it for at least 500 epochs to get the better accuracy. But the overall idea to make you understand how you can do the automatic text generation using Keras, LSTM and deep learning, by using deep learning. So let's go ahead and wait for some time. It is taking around half minute per epoch. That's mean it is going to take at least 50 minutes to complete this training. So by then, let's go ahead and wait to complete this. Then I'll complete the remaining code, in which I'll be providing a seed text, and then finally I'll be doing a prediction. Alright, now you see here the training of this model has been completed, and I have run it for 100 epochs, and out of this 100 epochs we have received 46% of accuracy. That neither we can say it's quite good nor it is bad. It is kind of okay accuracy, although you have option to increase this accuracy. Since this model has not overfitted it, so you can increase the number of epochs to increase the accuracy. So we have got our model. Now let's go ahead, add few cell here so that we can start running. Okay, so we have our model which is already trained in the model. Now, as I told you earlier, that we need first 50 sequences as a seed text so that we can predict the further the text. So the moreover, it needs just first 50 sequence of words so that it can start predicting the next word. And to do that, we are going to just select here random line 1 2 3 4 4 3, let's say. So this is the random line which I have just selected. So I'm gonna put this random line as a seed text, and once I put this as a seed text, then this algorithm will automatically generate coming words. And do remember one thing, this is not going to replace the exact play, but in fact this is the ML algorithm. So this is going to predict word based on whatever it has learned. And one more thing, you can change the words in this line as well. Otherwise, you can also provide your own set of words so that it can start predicting. But the one thing you need to always remember, that only to provide those words on which this model have learned. Otherwise, it might fail, because we have just trained it only for limited number of words. So the model can get failed if it gets a word which is not listed in its tokenization dictionary. All right, so let's go ahead and write a function so that it can predict the text, and that is the quite large function. So I'll explain you in the middle what I'm going to write here. So generate text sequence. So in this I'm going to provide here model, and then I'm going to provide here the tokenizer, which I'll pass here, and then I'm going to provide here the text sequence length. Okay, and then I'm going to provide here seed underscore text, which will be the first 50 word, and then I'm going to provide here the n words, I mean how many words I need to predict in future. Okay, so here I have text is equal to an empty list. So I'm gonna do a for loop here. So for I'm not gonna use this index. So for in range the number of words, so I need to iterate how many times. So the n words define how many number of words I want to generate. Then I need to create an encoded sequence for my text sequence. So that is the encoded data that I can get with the tokenizer. And then tokenizer dot text to sequences, and in this I need to pass here seed text. So I'm going to pass seed text. Seed text is 51 word, but I need just a 50 word, so I'll truncate that later. And this 0 tells that, okay, 0th dimension of this array, which contains the encoded text, actually text, and that text is encoded into number. As we had seen that earlier, every unique word has been assigned a particular integer number, and that integer number this is going to return into encoded. And since this encoded text might be larger than the 50 words, so what we need to do here, we need to truncate these sequences to the fixed length, so that we can do the encoded is equal to pad sequence, okay, which we had earlier. In the pad sequences, I need to provide the sequence which I want to pad. There I have encoded, all right, and then here I have max underscore length. That's the max length. The max length, I just need the text sequence length, which is the 50. Text sequence length is 50, and then the truncating, I need to provide here truncating as pre-truncating. All right. So after this, we need to predict the probabilities for each word. That we can do y underscore predict is equal to model dot predict classes, and inside this I need to provide this encoded sequence, which is encoded integer from text data, and then I'm just gonna leave verbose as it is. And once I have got this y predicted, that is the word, now I need to get it what is the index for this particular word. That I can do with, let's say, the predicted underscore word is equal to the null, and then I need to provide here a for loop for word index in tokenizer. Okay, so here with tokenizer dot word index, then dot items. So for each of these item, each of these word, I'm gonna see whether this y pred is matched with this word or not. Okay, so for this, if index is equal to y underscore predict, so y predict gives the index for that particular word. So if index is equal to y underscore predict, that means the predicted word is equivalent to word. Okay, once I have got the word, I need to break it here, and after that what we can do, we can do seed text is equal to seed text, and then here plus, now add this predicted word in a seed text. Okay, and then finally text dot append, okay, so here text dot append, and then finally the predicted word. I'll tell you this, let me complete this code first, and then finally once it is done, and then return all the text with join. So what is happening here, I think this is the predict, this is y predict. Okay, so what is happening here, the y predict, you understand that this will predict the class that will be the integer value, and that integer value I'm gonna match with the tokenizer word index item. Once that integer value is matched with the index of the word tokenization, so at that particular integer value, the predicted word has been taken from the tokenization. Once we have got the predicted word, we need to add that into the seed text. As you remember that here earlier in the seed text, we need to put down this into seed text so that the next word can be predicted. And similarly, this predicted word will be put into the seed text so that the next word can be predicted. And then finally, the predicted word I am adding here into a new empty list text, and then finally it is being joined to create a complete sentence. Perfect. So let's go ahead and run this function. And now what I'm going to do here, I'm going to call here generate text sequence, in which I need to pass here the model, and then I need to pass here the tokenizer, which we already have the tokenizer. Along with that, we need to pass here sequence length. The sequence length is 50, and we also need to pass here seed text. Okay, so seed text which we have got from line 1 2 3 4 3, and then finally I'm gonna put here generate next 100 word. Okay, so let's go ahead and run this. You will see here that it is saying that paired sequence got unexpected key argument max len. I think here this is wrong. This should be the max len. Okay, so let's go ahead and run this Yes, perfect. Now you see here I have generated next 100 word. Even you can just generate 10 word for simplicity. So after providing a seed text, which you see here, we have seed text. This is the seed text. After providing the seed text, this has predicted these next 10 words after this seed text. Alright, you see here the preposterously be stained to leave for them when thou art. Okay, and here this is not very bad actually. Whatever the Shakespeare has written, this model has learned that, and after learning those, it is automatically generating these sequences. So you see here, now I have generated the next 100 words. Thou art conventions, and we pour their natural fortune grace, the other fool as a monkey, I cannot. The things you see here, it is very good predicting into the verbs and auxiliary verbs like I cannot weep, and ends you clone, nay, my lord has aside the queen. So these are the words actually which is present into the Shakespeare's the work. Alright, so the most of the word might not be in the dictionary nowadays, like here, though this could be the wrong in nowadays, but these words are included into the Shakespeare work. That is why it is being predicted here. Alright, so in this lesson you have learned how you can do automatic text generation using Keras and LSTM. I am sure it might have helped you a lot to understand the word embedding, how to use the text data to encode it into the integer values, and how you can use Keras, TensorFlow and LSTM. Thank you so much for watching this lesson, and if you have any question you can comment below, and please do not forget to like and subscribe this channel so that you can get updates directly into your inbox. Bye bye, have a nice day.